blackout, the memory is quickly forgotten. Of course, not all levels of drinking result in blackouts. They happen when the BAC exceeds a certain level, approximately 0.16. But how does alcohol cause these memory lapses? In 1969, Dr. Donald Goodwin gathered a group of study participants and asked them each to recall the object he'd shown them 2 minutes prior. The twist? All the participants were very intoxicated. Despite this, most could pay attention to the task and correctly name the toy they had just seen. Yet, when Donald asked them to recall that object a mere 30 minutes later, half the participants drew a blank, having blacked out the earlier moment entirely. The study illustrates the strange and somewhat selective effects alcohol has on the brain. Many intoxicated people can perform complex tasks like holding a detailed conversation or navigating a walk home. Yet, for those experiencing what is known as a blackout, the memory of these events is quickly forgotten. So how does alcohol cause these memory lapses? First, let's identify the culprit. While a single drink often contains hundreds of different chemical compounds, ethanol is responsible for alcohol's effects on the brain. Ethanol is lightweight and lipophilic, meaning its structure easily dissolves into fats, like those in the membranes of the outer blood-brain barrier. Once inside the brain, ethanol's unique structure allows it to bind to, interact, and affect many different neuronal receptors, impairing pathways that allow you to make careful decisions, control your impulses, and even manage your motor skills. And the networks that control memory seem to be especially sensitive to alcohol's effects. Typically, information about your surroundings is taken in by your sensory organs and sent to the brain. Neurons transfer this information to one another via chemical messengers called neurotransmitters, which are released by one neuron and received by receptors at another. When a neurotransmitter binds to a receptor, it unlocks an internal channel, allowing small ions to flow into the cell. If enough ions enter the cell, the neuron fires, sending the signal forward. Through this process, different regions of the brain can communicate with one another in milliseconds, creating our moment-to-moment understanding of the world. But ethanol interacts with receptors, making it harder for neurons to communicate. While compromised, the brain is still able to transfer information, which is why many intoxicated people seem somewhat capable of performing basic tasks. In other words, brain function is highly impaired, but not completely broken. But memory storage is a different story. The transfer of moment-to-moment understanding to something we can remember is thought to depend on a process called long-term potentiation, or LTP. LTP happens throughout the brain, but is especially important in learning and memory regions like the neocortex and the hippocampus. During LTP, the firing of a neuron triggers physical changes to its structure. For example, more receptors may be moved to the cell's surface, making the neuron more sensitive to future signaling from its neighbors. These physical changes increase the likelihood that a cell will fire again at that connection, strengthening the wiring between neurons. And through this stronger connection, it's thought that a stable memory is formed. Yet studies suggest that ethanol has a unique ability to disrupt LTP, blocking the physical changes needed for memory formation. So while moment-to-moment information is encoded and understood, the storage of that information is blunted, resulting in a blackout. Of course, not all levels of drinking result in blackouts. They happen when the concentration of alcohol in the blood, or BAC, exceeds a certain level, approximately 0.16. But there's no magic number. At slightly lower BACs, brownouts, or the spotty memory of events, can occur, as some neurons continue to function properly while others fail. And drinking too much can cause a person to pass out altogether. Other factors like dehydration level, genetic differences, medications, and even how much you've eaten can affect the likelihood of a blackout. And teenagers appear to be especially vulnerable due to the substantial changes in brain development during those years. Alcohol's short-term effects usually don't last longer than the time it takes for the body to metabolize it, or about a day. But repeatedly overdrinking can damage neurons and permanently impair memory. It can also harm other organs, like the liver, which works overtime breaking down alcohol. After all, experiencing a blackout or witnessing others in this compromised state can be a lot for your mind and body to process.